Hide that and get back to my slides. There we are. So I think it is about 10 o'clock now. So we can sort of start going, and I'll start off slow for the people that are still shuffling into the class. That say this is where cottage is. I'm not down there this week. I'm back in Halifax, but I'll be heading back there on the weekend, I hope. Weather's not been great though. Today we did get some nice sunshine. So uh, for this class, I've got my 8:30 class. So at 7:30, Dora had me out for a morning walk, and this is the Northwest Arm. So I think last class I showed you the Bedford Basin that Osama took from his apartment. That was Halifax. If you are not from Halifax, is a peninsula. It's a piece of land that sticks out into the water. And on one side, we have the main harbor, and the back harbor, or the inner harbor, should I say, that's the Bedford Basin that you saw last time, the container pier. And the other side is what we call the Northwest Arm. And that's not far from where I live. And so I could walk there. And that's where Dora will often get me to go for the morning walk because it's just close at hand. And my street, they'd put a whole bunch of salt on, so we couldn't sort of walk around the neighborhood, burns her paws. The picture here, if you don't know the Northwest Arm, it's a very nice, peaceful spot. There are only a few good places to be able to view it. And this is looking out towards the ocean, though you can't see the ocean here. There's a little bump on the right. That's what we call the Dingle Tower, or Fleming Park, after Sir Sanford Fleming, the fellow that came up with standard time and built railways and that sort of thing. It's just this funny stone tower. I'm not sure its purpose. And there's a bump just over here on the left. That's the Loyola High Rise building, a residence on campus. So give you a sense of where we are. So I'll often give you pictures of where I am. But class hasn't been sending me pictures of where you are. Please send me a picture of a place that you enjoy. Just next time you're out walking, take your phone out, take a photo of a spot that made you happy that day, and pass that along. So, a few reminders. Quiz number 2 is coming up on Saturday. Every Saturday, you got a quiz. Many of you have already done it, and that's the best thing, is to try to get it out of the way as soon as possible. That if you haven't done it yet, that what we cover in the lecture today should answer pretty much everything for the quiz. That the material we do on Monday is Excel, and I don't think there are any Excel questions on the quiz. And then test number 1 is coming up in another 10 days or so on the 22nd, Friday. That I'll turn it on at 1 o'clock in the morning. It'll get turned off at 11 o'clock at night. It's 60 minutes long, so once you get started, you've got to finish it in 60 minutes. If you run into problems or if the test shuts down on you, we had that happen with a few students, get after me. I can solve the problem. We'll find a solution for you. It's just going to be like taking quiz 1 and quiz 2 and gluing them together, but only having 16 questions altogether. So it looks like quiz questions. That it counts towards 8 points towards your final grade, which is actually quite a lot. Only on chapters 1 and 2, so it only, again, covers the types of things on quizzes 1 and 2. I'm getting a sample test up and running shortly. I'll get that posted and let you know. And it'll allow you to go in there like it was a real test. And so we'll see how you can see what that environment looks like. I always encourage students to do a practice run. Used to be with this course when we had a big final exam, and we used to run it in the field house on campus, big gymnasium, which is a very scary place. And I used to tell my class to go over to the field house once they've set it up for the exam. And if you can get in there before exams start, go in and sit down in the room and just sit there for 5 minutes and see how it feels so that you can psychologically prepare. If you're interviewing for a job, and if you can get into what the interview room's going to be, go in and sit down there for a minute. Set your mind at ease. Get familiar with the ambiance, the feeling of the space. Same thing with a test. That we're trying to assess your knowledge, skills, your understanding. We're not trying to assess your ability to cope with a different environment. And, anyway, you'll notice if you've done quiz 2 that there are no, I don't think I put any Excel questions on it. Shouldn't be. There's no Excel questions on test number 1. That Excel is we're going to be getting into on Monday, and for the next 6 weeks or so is going to be Excel every day. That there will sometimes be Excel questions on quizzes and on tests, but I generally try to keep it quite limited because it's not what I want to test you on. It's not a priority within the course. But there are some things that are related to that that are important. So again, where are we at the moment? Um, we've defined data analytics, emphasized that it's a process. And the process starts with defining a problem, a business issue, and how do we work through and address that issue with data. And there are special tools that we use along the way, but it's in part what we're going to be talking about today is that starting point of moving from a business issue to a data issue and inform that decision. And what's the process that we go through? That how do we decide what data we need? Where do we get it from? What does it look like? That's much of an emphasis on Monday when we'll look at a real data set, not just something out of a textbook. This is data. It's 10 years old, but it's still data is data. And we'll be raising a lot of issues to do with quality of data. And that's critically important. Um, our data is never perfect. We need to understand its imperfections. But just because it's got even some imperfections doesn't mean it can't tell us a good story. And Monday we'll be working on preparing that data in Excel for doing analysis afterwards. We're going to start at the very, very start of getting things prepped. So if you're someone that likes to cook, it's doing that boring stuff of chopping up the vegetables and organizing your ingredients and measuring things out, but you're not cooking anything yet, but you're getting ready to get going. And if you don't do the prep stage properly, you aren't going to be able to cook that recipe the way it should be done, particularly if it's a fast one. If you did do Thai cooking, you'll know what I mean. But I wasn't in this class. I think it was the other one, my 8:30 class. A student asked about a blog that I suggested that you take a look at. It's relatively short. I enjoyed reading it. Um, I'm not saying that you'll enjoy the same things as me, but it was one that was relatively quick and simple about doing some data analysis from start to finish. And it had some highlights of the process without getting into any math, really. And I like the way it told the story. And good data analytics is good storytelling. And when I think of good storytelling, that I'm more interested, I guess, in good storytelling to a 3-year-old or a 4-year-old, bedtime stories for children, where it's a picture book. Uh, but you've got to keep them engaged in the story. So hopefully they fall asleep at the end. So what you have to understand is a really good story involved an awful lot of planning and preparation. It may come across as great, easy, and obvious, but what you're not seeing is what went into getting that ready. And that is what a lot of the course is about, is getting that stuff set up and ready and to make it a good story. But we're going to work through right to the end of the pictures that go in your picture book. So I'm going to tell you two. One of them, I'm going to use the Hillary one and just highlight a few things there. And then I'll talk one about COVID, since we always talk about COVID. So This one, the woman that wrote the blog, first name is Hillary, and she wanted to write about how, to some extent, she hated the name because of the connotation that was associated with it. And she viewed it as, although it was a nice name in certain respects, it was poisoned. Um, and so we have to work through, well, what do we mean by, how do we define what is poisoned? What is a poisoned name? What do you mean by that? And the way she tried to describe it as a name whose popularity dropped by a huge amount, that it may have gone from being very popular to being very unpopular. So there was a big decrease. But what do you mean by that? There are a bunch of other questions. Do I care about, is Hillary the first name or a middle name? Things get harder to analyze actually if I have to get into middle names and everything else. Sometimes I don't know middle names, I just have the initial. Uh, does the spelling matter? Uh, is it Hillary with one L or two L's? And I guess there's quite a, it's commonly spelled one of the two ways, but at least there's only two common spellings. I think of a number of years back, I had in one class 4 students all named Kaylee in the same class, but they all spelt their name differently, with C's, K's, with some with really simple spelling, some was really long, a really long name. I don't know if it was trying to spell Kaylee with the largest number of letters, but I guess parents wanted to be creative and to be different, not be the same as that other Kaylee, whatever that was. But that makes our data analysis more challenging, and it may be important what the spelling is. But measuring decrease, do we mean the decrease in frequency, that there are fewer babies being named Hillary? But the population is changing over time. So as the population gets larger, we might have more people. So maybe it's decreasing, but we're not seeing it because there are more people to begin with. Maybe is it relative decrease that we should be looking at? Percentage change? I don't know. There are a bunch of those things. That they there are some names that just come and go. That because of a character in a movie or a TV show, a singer, that the name suddenly becomes popular, and then a few years later you don't hear it anymore. And where do you get the data from? Where do you get all that birth data from? That those were some of the questions that Hillary had to think about in planning this through. And it turned out she was able to find a source to get the data, but there was a certain amount of cleaning, transforming, smoothing, tidying up of the data to be able to draw conclusions. But the key parts of the blog where the story ended up being as pictures. And though there was which picture to use, and she used several pictures in the blog. One of them was just a time series. She had data going back to 1880 of newborns, the names of newborn children, and when their birth was being recorded, what name was recorded. That uh, and she looked at a variety of different names, and because it's not just look at Hillary, let's look at all the other ones to see which ones are popular or not. And so she looked at ones with big drops at some stage from their most popular to least popular, I guess. And there were 14 names there. The Hillary is this purple sort of one that was going up from about 1950, 1960, and then peaked around 1992 or thereabouts, and then crashed. And that was when 1992 was when Bill Clinton was elected president, and Hillary Clinton, his wife, was got more attention. That she was well known in certain quarters before then as a state senator, but this put her very much into the limelight. But we've got all these other ones in here. These are ones: Ashante, Katina, um, Farah. Farah, I can recall, that was Farrah Fawcett, Charlie's Angels. But they were a flash in the pan. They went up and down. So let's take those out. They're not really, they don't belong. So if we take those out, we see, yeah, Hillary stands out in that sort of thing. And this is a nice, simple graph, and it emphasizes that change and the sudden change, the sudden drop that fits with that. So there's still babies being called Hillary, but it's the dramatic drop of names that is that's what's meant by being poisoned, or at least in the definition that the blogger used. Also looked at others over time and just looking at how popular they were. And you have others that became, as a percentage of newborns, remember, uh, much smaller population back at the turn of the century, but Marion was a very, very popular name back then. And here we have the two spellings of Hillary. And here we've got some other ones that come and go. But these pictures by themselves, with a little bit of information along the top, tell a very good story. That's what our goal is at the end, to have that type of thing. So if I go back to the spring and the debate about COVID and us putting in place lockdowns and wearing face masks, a lot of different sorts of issues, there was a lot of debate whether or not this was a hoax or fake news, including the US president raising it as being, it's not a big deal at all. That And there were people saying, how do you know that this person died because of COVID? That should we believe that? And that, and in the early days, the vast majority of the people that were getting COVID, and particularly the ones dying, were in nursing homes, elderly people, over 80, 90 years old. Come on, they're old. They're going to die anyway. That's a very cruel statement, but people were making them publicly. Um, that it's not a big deal, and it's just so they died this week instead of the next week. They were going to die anyway, and probably soon. And then others saying, look, there's variation. Things go up, things go down. It's like fish stocks or other sorts of things. We have good years, bad years. So, maybe deaths are up this year a little bit, and maybe this is one of the up years, and next year it's going to go down again. How would we define this problem, and how would we create a compelling message? And I can't use a lot of words. I can't use a lot of graphs, tables, and pictures, because I'm trying to convince people that the more information I give them, probably the more they'll think that I'm trying to hide something behind all the numbers. I'm making it complicated. Can I make it really, really simple? And Statistics Canada and the Nova Scotia Department of Finance put a report in their daily stats just before Christmas that did exactly that. Because my statement is it's having a devastating impact on mortality in Canada. I'm not saying they're dying of COVID, but COVID, I think, is the cause of mortality. So there were two pictures they put out. Well, there were a bunch of others if you read the whole report. One was a simple graph, number of deaths per week per million residents from January 1st up until the end of November. So it's over these 44 weeks, or early November, maybe it was. And it showed for 2016, 17, 18, 19, 2020. So the yellow line is this last year. And we'll see it's different. It has a bump. And this is in the spring. This is back in April, May that we see this bump taking place. But you can see there's variation from week to week. We seem to get more deaths during the winter months. I'm looking from March to this is at the beginning is the end of the winter into spring. Here's July, August, and then we're into the fall and getting colder again. So there are patterns by time of year. This is a very busy graph. So they presented another one. It's also busy, but it's a little bit finer tuned. I don't really care about the year-to-year variation. What they did is they said, this is the expected number of deaths we should have. On average, how many deaths we should have by time of year. And here I've got date along the bottom here, so it's more informative. I've got some bands, these dotted lines above and below, saying, yes, it does fluctuate, but it shouldn't fluctuate outside those bands. So when it goes outside the bands, pay attention, something's happening. And even the beginning of the year, we're right down at the rock bottom. It was unusually low number of deaths just before the onset of COVID. And then we see the blue line and see the bump. Or you can summarize, since we're comparing to, let's show the difference. And these are what are called excess mortality. They're deaths beyond what we should expect to see. And as we can see, we had in the spring a bump, a little bit during the summer months that were unusual, but we were still getting it every month. Okay, we weren't getting ones going below. So we are still accumulating. And then it looks like we're starting to go up again. And this was where the second wave has hit. So we'll probably see this if they repeat this in the spring. We'll see there's a new bump that's coming out here. So this is a very powerful picture to tell the story. And all we're saying is these are deaths, people that died. I'm not saying they were due to COVID. They could be what could be they died because they didn't get heart surgery, didn't get the heart surgery because the hospitals had closed beds because of COVID and they weren't doing surgeries or putting it off. So it may be indirect impacts. They didn't die directly. In BC, there's a significant increase in the number of drug overdoses. That they have a very, very serious problem there with drug overdoses. And because of the support services for homeless people can't be provided because of social distancing and a variety of those things, uh, that they've seen a big spike. Are you going to say they died from COVID? They didn't die from it directly, but as an indirect consequence, probably because of having to change supports for those individuals. But so these, but the big change that took place during this time is COVID. So we can, I think, legitimately say those excess deaths are due to COVID. This is what I mean by trying at the end. So this is giving you vision, and this is the last part of the course. We'll be emphasizing good pictures at the end of the course, but we will be looking at as we go through. Pictures are an amazingly good communication tool for trying to get our message across. And we often should be thinking about what pictures would we like to create. How am I going to get the right data to be able to do that? How can I come up with an appropriate measurement system to be able to convey the story I want to tell? So um, that they uh, that and I like simple pictures. They tend to tell more powerful stories. That so good data analytics is generally good storytelling, and an important part of good storytelling is having good pictures. Ask any small child; they like the pictures in the picture books. It really, for them, makes the story come to life. But to do it, you've got to put a lot of thought into the process. What are you really trying to say? What's the message you're trying to get across? We're looking at data ones. So how can you measure it? We've got to think about cleanliness of the data. And with the Hillary stuff, taking out the fad names and things that really don't belong. With this one, not clear what cleaning we had to do, but try to keep it as simple as you can. This is generally fairly hard work. For many, they find it boring. Unfortunately, we got to do it. So we're going to start in on the boring stuff, and I hope you don't find it too boring. I find it fun, a lot of it. Um, so we're going, if I go back to that Chris model, I should show you the picture again. It started out business understanding and into data understanding and then other steps. So let's start at the business understanding, and I'll just give you an example of a business problem. This was the type of thing that uh, I used to be asked about when my responsibility was enrollment, particularly undergraduate student enrollment at the university. So that had two portions. One of it is how to get more students in the door, a recruitment problem. And then once I got them in the door, how do we keep them? That's a retention problem. So, uh, and they were concerned about enrollment because, you all pay us money. And that money is what makes the institution function, allows it to do what it does. So how do we improve the revenues of the institution? That, in a very crass sense, was the issue that they had of generating more revenue. That how do we then start translating that? So it's a really complicated issue, and maybe someone thought to distill it down to one component of it. And suppose I was asked to write a report for the president or the vice president or something, uh, asking about um, student finances. If your student association would probably start out saying one of the most serious problems they see is student finances, and that's a broad thing. That's the cost and the resources to pay for it. But it's how do I talk about how student finances are affecting students? It's very, very fuzzy. I need to define it more. So as we're working through this, we've got to define things better, more clear questions. So they might have defined it as, to what extent are the increasing costs of university education and limited student income affecting student academic and personal success and health? There's a big mouthful. So I'm looking at finances being both the expenses you have to pay and also the resources you have available to pay for them, because there's two components to finances there. And then, why do we care? Just money. Is that our issue? No, it's because it has an impact both academically and non-academically, your personal health, success, um, whatever those things mean, because again, those may present challenges. But I'm looking at how does A affect B? Generally, looking at one thing by itself tells us nothing. We're looking at relationships. And so we should be expressing our question probably in terms of a relationship. So I'm getting a little closer to it, that I'm defining what I'm relationship has inputs and outputs. So I'm narrowing the scope of inputs. It's expenses and income, and my outputs are success and health, both from an academic and personal perspective, whatever that means. That's put some boundaries on it. If I put this out, some might say that I'm biased because I said, without any data yet, that costs are increasing and that your student income is limited. But those are both true statements. That the um, they're just to emphasize why this is important and why this adds a time dimension to things. So why is this a problem today, and maybe it wasn't yesterday? It was yesterday too, but maybe why is it more of a problem? So trying to convey some urgency to it, make it worthwhile to go and study the problem. I'm, I'm trying to convince people along the way why I should be doing the research, why it's important for them to listen to the answers. So I'm getting closer to defining specific questions, but they're still too broad. So now I've got to go and, can I define individual specific ones that I can get answers to those specific ones? Very precise answers. Yes, no, 15,000, or a number or words or something. And if I take all of those together, they tell me the answer to my big issue that I'm trying to phrase. But I've got to get it down to precise things, because we're going to be looking at how data can help us and answer specific data questions, which become precise. So I may have ones, okay, what do students have as sources of income or resources? That So I may be coming up with a list of where they are, but then I'd probably also be wanting to know, well, and how much money do they get? On average, what's the lowest? What percentage of students have access to government student loans? What percentage have access to employment while going to school. On average, how much do they earn? How much are they able to borrow? So there are a variety of now even more refined questions that are measurable type ones. But even within that, I'm not even saying how I'm using that income or relationship, but I talk about students. Students aren't one thing. They're different. Different students are different, and they're different populations. So maybe international students don't get access to Canada's student loans. Is that something that should be relevant? Because that's a source of income to one group, but not to another group. That in terms of their ability to earn money, does that vary across student populations? That surveys, that the student survey, like the one I've asked you to complete, is that I'll probably find that domestic students are able to earn more in the summer than international students are. They may have access to jobs that international Canadian students may, because of the networks they have or knowledge they have, or bias of employers or whatever. Their earning potential is different. Um, who earns? Who doesn't earn while working? Who works, should I say? That how much are they able to earn? And what you'll typically see is students that are missing certain financial resources, like family money to pay their ways, have to compensate that by getting the same money, because their expenses may be similar, by getting it from another source, work. Years ago, I used to study the business students a lot, and uh, I used to try to get as much data as I could about students at Dal and at Mount St. Vincent and Acadia and St. FX. If I looked at uh, students at Dal versus St. Mary's, were neighbors to one another. It was interesting that uh, twice or more, that the number of students working while going to school is at business students is probably twice as much at St. Mary's than it is at Dalhousie, much more than at Acadia or X. But that might be because there are more jobs available in Halifax than at Acadia or St. FX. But Dal students have access to the same jobs St. Mary's students do in Halifax. What's the difference? Well, about half of the business students at St. Mary's come from Halifax. We're very concentrated in, it's their local students. Dalhousie, more than half of their students come from Ontario, particularly the Greater Toronto area. So those students have enough money to leave home and come to Halifax to go to school. The student that is from Spryfield or Tantallon or Preston's or whatever around Halifax, they're probably studying at St. Mary's because they don't have the money to go to Queen's or go to Western or go away to go to school. So they have a different source, and they're making up for it by working. Those students from Ontario that are at Dal um, may have a lot of family money, and so they don't need jobs. It's a different demographic. So that you need to even understand that before we're actually looking at the impacts of these things. Getting messy. Does working affect mental health? Maybe important thing that there we're trying to look at inputs and outputs. So how are we going to measure mental health on the output? We've got working on the as an input, stress, all of the. But we're getting down to more specific questions. They're ones I can draw graphs of. I can summarize. I can. That's what we need to get to. Don't race ahead yet. Step back now and think, if I could answer those sorts of questions here with numbers and that, and there's a lot more questions, and I had the data to get them, could I go back and answer the first question? And if I can, then I'm on the right track. If I'm still saying, well, it's nice to know, but no, it doesn't quite answer it, then I've got to work back and forth here. So from business understanding to 8 understanding, there's a lot of back and forth to make sure I'm collecting the correct data to answer the correct questions that will resolve the business problem. at the beginning. And that can take a lot of work and take some real time. Uh, but at this stage here, my general recommendation is to envision the future, like those pictures that I showed you before. That's what I want to be able to have. Is this going to lead me in that direction? Then I might ask, well, do I have the data? Because I may have some really good questions here, but we may find we can't get the data. But this is the first bit. So we're now formulating, we're moving at this stage, we've gone from the business understanding to a data understanding. And in data understanding, we'll start asking, where can I get the data? So there's some data I can get out of Banner. Pull some stuff about the students out of there. But the questions I had back here, um, I can get information about student loans. I can get information about scholarships. I know data about expenses. I know information about students that dropped out, retention, that sort of thing. I have data on grades, but I don't know about how much they earned. I don't really know anything about stress and mental health. So Banner has some data, but there's other data it doesn't have. So maybe what I'll do is do a survey, and that's another source to bring that data in. And for some questions, maybe there's a third party. And it's about a year ago, 2 years ago, we started seeing some early research where the Canada Revenue Agency, CRA, the folks that take our tax money from us, there was an agreement struck between CRA and Statistics Canada that allowed researchers access to tax data. And one of the first applications was some researchers at the University of Ottawa that took data out of their administrative database about graduates, and they linked it to tax return data on those students so that it had more precise data on their earnings while students, and more importantly, they wanted to study earnings after they graduate. And there's a lot of stuff you can indirectly pull out of tax data. If you're claiming tuition deductions, educational deductions, then you must be in school. There's a bunch of other, they could measure who was doing study after they graduated by who was claiming education deductions, that type of thing. There were a number of privacy issues that it took many years to get resolved before they could link that type of thing. But sometimes we can use that very granular individual data from third-party sources. But that generally raises privacy issues. And it's beyond the scope of the course, but it's something to think about. A big, I may have mentioned to the class last time, someone had made mention about Walmart, trying to get them to take out a Walmart credit card. And if you did, does Walmart now get access to your shopping behavior when your shopping did not take place at a Walmart store? Could they find out data about you using your Walmart card to shop at other types of stores? That's, in a sense, like a third party, in that Walmart, the store business, is separate from Walmart, the financial services lender business, where the credit card is. They would be two separate companies, but are they allowed to share data? That'd be important. Anyway, getting into some definitions about data. We'll talk of a population as being everybody. It's the huge group we'd like to talk about. So at the beginning, when I wanted to talk about how finances were affecting student success, I said students. Which students? Am I talking about students in a general sense? Canadian students, Nova Scotia students, Halifax students, St. Mary's students, St. Mary's business students? Which students? The population is the group that I'm going to want to make statements about. Whereas the sample is that generally a subset, a smaller group within that I actually have the data on. So I don't have data on everybody. Usually it's only a subset, but I'd like to generalize. And that in uh, anytime we're doing research, we're trying to take from what data we know to generalize about everybody, about the general population. And that will only work if our sample is reasonably representative. And uh, the if we can't get everybody, then ideally what we'd like is a random sample. So we're going to go out and pick a bunch of people to collect data from, and hopefully they all respond to it. So I'm picking them randomly. Word this week is that Statistics Canada is doing some interesting research on COVID by asking people for blood samples. This is a very different sort of thing. So you're getting an invitation in the mail, being asked to prick your finger or something, probably put the little bit of blood on a card, put it in the mail, and send it back to them. You know, so it's not they're going to suck it out of your arm in a big sample, and they're going to use it to find markers and evidence of uh, COVID among the general population. That so they've randomly selected thousands of Canadians to participate in this, so they'll get a picture across the country. It's crazy. They don't need to ask everybody. It would be enough if they could get a good sample of maybe 10,000 people. So they're being chosen randomly. But what's not happening is they're not forcing those people to send in a sample. So they're not saying, if you don't send in the sample, we're going to penalize you in some fashion. We're going to have you arrested, whatever. It's going to be mandatory. Uh, that that type of thing actually happens with the census that's done every 10 years. That 10-year census and certain other types of data collected, you can be fined, punished in some fashion if you fail to respond. Um, that it's unusual. There are a very small number of cases, but in that instance, and there are some sampling situations that the government does where it's mandatory that you respond. That way it ensures it's a good random sample. But that issue of it being voluntary or mandatory, I'll talk about in a few minutes, but it is important. But uh, normally the only way we can get a good random sample and control it in that fashion is to set it up as an experiment, like you would do a lab experiment in chemistry or biology or some of that nature. And I'll talk a little bit about that later. But experiments are often hard to do. Frequently, our data is coming from a uh, a database, a structured database. It's customer information that we've got in our records that we're pulling out of. Or for if I was in my past life getting student data, I pulled it out of Banner. That is a database. Banner has got all of the data about students that the institution feels is critical to its operations. And it's not one big thing. It's not like a big bin where we throw it all in. It's organized in little pieces. Uh, and generally, databases are organized that way into tables, we call them. And the tables are all connected. So Amazon has in one table, it's an address table for me, and it's got me and every address I've ever shipped to. And I've shipped goods to different addresses as gifts or that type of thing. That they've got another file that is credit cards. And so all of my credit card information, and as credit cards expire, they've still got the old stuff that's in there. And so they know that one time I was using a MasterCard and then I switched to a Visa. And one Visa was with Scotiabank and then the next one was with Toronto Dominion Bank. How they might use that, I don't know, but it's in there. They've got that. It's got other stuff, multiple databases actually having to do with purchase information about transactions I made, about different products. And around the products, there are data files for each of those different products. But they're all interconnected. So if they want to pull out, my last order they'd be pulling, oh, it was to this address with this credit card for these products, and it pulls it all back together again. But it's organized in a very complex fashion beyond the scope of this course. And really, you don't need to know how to work with relational databases. You're best to ask someone, a computer scientist, someone that has expertise in doing the extraction to do it properly. It's easy to make mistakes. Speaking from experience, because I made lots of them. Computer scientists used a language that I heard it for years, but I never understood what they were talking about until eventually I figured it out. They talked about ETL, which when I asked, what's ETL? Oh, extract, transform, load. What's that? And uh, out of that big database, they've got to extract things, pull things out to put it into a file for me. And ideally, I would like them to bring it, the final file I get, I want to be a flat file most of the time, a spreadsheet. It's got columns, it's got rows, and all the files we'll look at in the course are that way. Each column is a variable. Your last name, first name, middle name, student ID, those are all fields or variables, attributes that I'm measuring. So in the survey, question 1, question 2, question 3, question 4. And then the rows are your observations. They're the records you've got, student 1, student 2, student 3, student 4. And usually they're unique. I don't get duplicates of that, but we'll talk about that. And so ideally, I'd like to have each thing I want to study as being a separate column, and each customer, each person, each object I'm studying is a different row. And that's what the final output's going to be. So they're going to extract it to put it in that fashion. Before they do that, though, they will often transform the data. So with my Amazon data, they're not going to take, there's so much stuff there. They might be interested in how often do I shop at Amazon? So what's my average number of visits per month? So that's going to be in one column. In a file on a student, maybe it's what's their cumulative grade point average. But I may also, what's the grade point average in the last term that they were here? So I've taken all of the grade data, averaged it, and put it in as one new variable. That's a transform data, and maybe average purchase, so some of those sorts of things. Maybe what is my most recent address? So out of all the addresses, it's not calculating something, it's just taking the most recent one. That, in a sense, is transforming it because it's selecting from that group. So when transforming, it's not just arithmetic, but it may be a sorting, filtering function that takes place. And then when I get it in, that's the transform. When that's finished, then they load it, and I get my spreadsheet that I work with. And you have to think through it, that at the transform, it's to be able to get the numbers you wanted to answer your questions initially, because the data for the question that I posed, maybe I asked, well, how much money does a student have in scholarships and bursaries? In the database, there are multiple scholarships and bursary accounts and that sort of thing. So in the transform stage, I'm going to bring all of that together and total it. That's what I'm going to put into the spreadsheet. So there is important to understand these things. So for the computer scientist to give you the data you need, they need to be able to have a good understanding of those specific questions and what those variables are that you're measuring. And so there's a whole bunch. I can bring out a banner, a lot of different stuff. Not everything that I might like. It may not be there. That I can get a lot of data, but it may not be what I need. So I may have to find another way of doing it, or it may not be exactly the information. That a common one is trying to do analyses on where students are from. And I've got some address data and citizenship data that isn't quite exactly what I want. So their address may be Halifax, their citizenship may be Syria. Oh, good. Probably, which one do I use? Both are wrong. That student came to us from the United Arab Emirates, UAE. That that it wasn't a direct movement that we had. So it still may not be perfect, but I've got to explore some of those sorts of things and figure out what might be missing. Maybe I have to change my question. Maybe I have to look at something else. That uh, maybe I have to pull it from multiple sources, and that can be messy when those sources don't agree, and we sometimes get that. But a very common source that we'll use is surveys, and that's what we're using in this course, is to get data about you. If I wanted to study the impact of COVID on students, to do that, I needed two data sets. One, to do it properly, um, is data from before COVID existed, and I've got data from this class from January of last year, and then data of you today. I could ask you, just if I didn't have two data sets, how do you think it's affected you? But that's going to be opinion. Maybe I'd like to be able to know if your opinions are valid. So having specific data one year, specific data another is going to be useful. Unfortunately, I can't measure the same student twice, but the student a year later is a different student anyway. It gets messy. Uh, that so surveys can be very powerful in getting data on things that aren't in our administrative data, but they are more challenging to collect it. And usually I can get data on thousands of students out of Banner, but I'd be lucky in a survey to get more than data on several hundred students. That it's different challenges to get different data. And if I merge them, that we may run into problems of merging those. Uh, an important one is ethics. I'll get to that. So um, the I may get some missing data, that I've got the students' data in Banner, but they didn't answer the survey. So what do? I've got half the data, but not the other half. Privacy and permissions is a big one with survey data. Normally with surveys like the one doing with you, I guarantee it's anonymous, that I don't know who you are. And if I did know, if that was there, I would ensure that I had never disclosed the identity of individual students. And it helps get us more honest data from the student. And you'll answer differently if I know who you are. That when people are asked about how much their earnings are, uh, very high income earners and very low income earners often are uncomfortable disclosing those numbers. They're embarrassed one way or the other. And it's hard enough to get it even when it's an anonymous survey. But when they know who you are, you're not going to get it at all. They'll refuse to participate. If I wanted to link your data in the survey to stuff in Banner for things that I didn't ask about you, the only way I could do it is to know who you are. Because how do I link your survey to stuff in Banner without having something in common between the two that uniquely identifies you, like your ID number? And so there, unless I had your permission to do the linkage, I wouldn't be allowed to do that. That there's a lot of ethical issues, and it gets complicated. Is all I'm trying to point out. So you know, on one level, you may think, oh, I could do this and I'll get answer to my question. Maybe you're not allowed. So you have to be careful. So um, response rates with surveys in particular, but also with administrative data, is a big issue. That missing data, we're going to find, keeps coming up as an issue. We are missing some data in Banner about you. Uh, for a large proportion of students, we don't have valid address data on you. We don't know exactly that we have an address when you applied, but we don't know what the address is that you have right now, because we've been dealing with you electronically and not by Canada Post. And so that data has not been kept up to date. So we've got a lot of missing stuff. With surveys, that's the single biggest problem with surveys. The I So far we've got about 50% of the students in 1206 across all 8 sections have participated in the survey. I'm going for 75%. I still have a ways to go to get the sample I want. We've got about 170 responses out of about 340 students. I'd like to get at least 250 responses. In the previous 3 surveys, we hit the 75% mark, very close, between 72 and 76%, which was excellent. That we're going to be working with starting Monday, a data set. It's on Top Hat. It's in the week 2 folder. There's an Excel file from 2010 survey data. And it's used in chapter 2. We'll be using it in class. That it was a survey done in 2010 of all undergraduates were allowed to participate, but we only had 15% of the student body actually participate, which wasn't that bad. There was 811 students. Many would view that as quite good. A survey participation rate of 15% is not uncommon. Many surveys have participation rates of less than 3%. The challenge is, what do you do with the other people? What do you know about those that didn't answer the survey? And in the previous class, that students in the chat started asking me, like, if a quarter of the class doesn't answer, how does that affect our results? What can we say about them? They didn't answer, so I don't know. I'm ensuring this is anonymous, so I can't actually track who they were to go back and find out, were they male, were they female, were they Canadian, were they international students? Did they have good grades last term or bad grades last term? I don't know, because they didn't tell me, and it really distorts things. Some of the things I can work with. So in the 2010 survey, the body that collected it, it was a national survey. And we've got the St. Mary's data from it. They knew in the initial data set that they were given to invite students to participate, they knew our gender split, what percentage of our students are male and what percentage were female. And in the survey, the response rate from females was higher than that for males. So much so that they ended up with some of the analyses that the group did that collected this. They weighted the observations because there were so many more women than men in it. It was going to be biased in reflecting potentially a female perspective on that issue, whatever it was. So when they were counting things, or measuring a lot of things, they weighted it. And they might say a male gets a 1. They're counted as a whole person, whereas a female would only be counted as a 0.8 person or a 0.7 person, because so that we'd get the appropriate gender balance. And that's a common strategy, is doing some weighting, but we can only weight on certain things. I could get data to find out of the students in this course, what percentage are male, what percentage are female, what percentage are Canadian, what percentage are not, what percentage are this, that, or the other things that are in Banner. And I could try weighting things. But does that suppose that the real difference is mental health? That those that didn't participate are very fearful and not engaged and hiding under the bed, and they don't want to come out, and they are terrified and are experiencing serious mental health issues. And they're afraid to participate in anything, including the survey. Then they're heavily concentrated in the missing 25% and may not, and maybe then underrepresented in that other 75%. I'll never know. So it's a problem. These are examples of problems we get with what we call an observational study. That's working with the data that we've got. We didn't control anything. We're not controlling who's in, who's out, how they respond. We're not controlling the environment. So there may be other environmental factors affecting the results I'm getting. And I don't know what they are because I couldn't control it. So if we want to ensure that we're not getting deceived by other environmental factors, we really should have an experiment. And I'm going to talk about that soon. Even administrative data, in certain respects, can be seen as being observational. We've not controlled the data collection of it. So the alternative is what we call experiments. And at one time, we thought of those as things being done in the lab. In psych courses, they're always trying to do experiments with students. And so you agree to join in the experiment as a participant, and they have one group under condition A and the other group under condition B, and they see, like your little lab rats, what happens, what you do. That the only problem they have with that is the students that agree to participate in the experiment may be different from the general population. And so even though you've got control over the two groups and the treatments for the two groups, they're not typical. That's arisen in medical experiments where for years they used to test out new drugs on healthy males, or at least males, not females. And so they found the drug is effective. But they didn't realize there are side effects for women that weren't present in their experiment because they didn't have any women in the experiment. We've got that with the vaccines for COVID. It's only been tested on certain populations. And so we don't know how the vaccines will work on other populations. But we've controlled other aspects in that environment. You'll hear a lot about it in online marketing with what they call A/B experiments. It's become very popular in the last 10, 20 years. So when you're online and you see an ad pop up in the corner there, it's in a dark blue, it's got the typeface is white, it's got a little picture, or it's got a video in it, or some activity in it. Someone else gets the ad for the same product, but it appears in the bottom right. It may use a slightly different color, but it's a different version of the ad. So we've got version A, version B. And it's randomly presented. So even if you go back to the same website, or they throw that same ad at you again at a different time, it may be one time you see version A, one time you see version B. But what they're tracking is how you respond to it. And they collect data on tens of thousands of people that interact. And from that, they see, oh, when they see ad A, they do this. And when they see ad B, they're more likely to do that. And those are good controlled experiments. And we can generalize. Even though it's a sample, we haven't done it on everybody. It allows us to generalize to the population as a whole. And what they do is they find which ad is more effective for what they're trying to achieve. They tweak the ad, do that, and then they change something else. And they're constantly tweaking little features of it to improve those response rates, the way you interact. But we think of those as treatments. They can do it in advertising. It's not painful, it's not hurting you. But there are many instances where the treatments, it's not ethical, where you're withholding a treatment from one group, giving it to another so you can see the effect, to ensure there isn't a placebo effect, that someone thinks they're getting the treatment, but they're really not. They just got injected with saline solution. It's not going to prevent COVID or do anything to them. Others got the real vaccine. They compare the two groups over time, find the ones who got the real vaccine did better. Maybe the ones that got the salt water solution did better too. That we call a placebo effect. They got better because they thought they got the vaccine when in fact they hadn't. But suppose that not withholding treatment on one group led to this person dying or having at least negative health effects. Is that ethical to do that? So that you could get better data, do a better experiment, someone had to suffer in doing that. Not fair. So experiments may have problems, and there are a lot of contexts we can't do it. That all of these things have to do with the quality of the data. How believable is it? Is it reliable? Is it going to tell us what we wanted? So when we look next week at this data from the survey from 10 years ago, one of the questions is the same as what we had on our survey. How much did you earn last summer? And do you remember how much you earned? How accurately do you remember? Most students gave answers 10 years ago. There's $1,000, $2,000, $2,500, $3,000. Nice round numbers. Someone said $9,655. How did they know? How could they get it so exact? There were some that gave very precise numbers. One student said that they earned $650,025. I think they earned 6,500, and that it was a typo. But I don't know. Maybe they're maybe this is a Saudi prince or something, and yeah, that's what I got last summer. Dad gave me $650,000. Uh, I don't know. Maybe it is valid, but we've got issues of data entry errors, bad memory, guessing. Some people want to mess with us and don't give honest answers. Maybe the 650 was just to mess up our study so that we'd have trouble. We'll find that some questions the student didn't understand what we were asking. And so they gave an honest, valid answer, but it wasn't to the right question. That we get a lot of these sorts of things. And even in administrative databases, we get these things. You may have made an error when you applied to St. Mary's. You were asked what high school you went to, and you had a drop-down box. Not often, it's common for people to pick the wrong one just because they misread the name, or it was in a list and they accidentally picked the one above or the one below. There are a variety of these things, and that messes up the quality of our data. Is it enough? We should worry about it. Sometimes yes, sometimes no. That so we should be asking ourselves a whole bunch of questions when we look at the data. So before racing ahead and doing your analysis, go and look at it, play with it, and look to see, is there anything in there that shouldn't be there, that seems strange to you. Don't throw it out. Go and investigate it, because it may be it's valid and it highlights something that you never thought about before. That maybe you've discovered something new in your data, that what's unusual to you might not have been to someone else. Ask yourself, does it seem reasonable? And why? Sometimes we get duplicates. Last year I made a mistake with the survey. We had students that went in, answered several questions, and then stopped. And then they came back, and the survey should have been set up so that if they tried to come back in again, it would pick up where they left off. But what happened is they came back in and it started at the beginning. So I ended up getting one response, incomplete response from the student, and then a completed response from the student. And I had these duplicates in there. So I was double counting something, the problem. So there are a variety of these things. We have other things that sometimes, and in the quiz, there were a bunch of questions about this, about the types of data. We're going to be looking at value estimation a lot. Those are numbers. And classification. Those are categories. And that those are some big descriptors, but normally they look at different scales of measurement. So on one end, categories might be nominal. Are you male or female or non-binary or something? Are you arts or business or science? Answers that are yes and no or maybe. Those are nominal names, words. But if there's an order to them, then it's ordinal data. So were you very satisfied, satisfied, neutral, dissatisfied, very dissatisfied? That's on a scale, an order to them. So ordinal data ones where the responses, the measurements, can be put in an order, in a sequence. And we might analyze those differently than nominal data. But both of those are sort of categories. Satisfied people, the dissatisfied people are like two different categories. The arts people, the business people, two different categories. With numbers, the distinctions are less, they're numbers, and on the surface, interval and ratio data may look the same. The difference is you ask yourself, can I take a ratio? So if you earned $4,000 last summer and someone else earned $2,000 last summer, you earned twice as much. I can take a ratio of the two, your earnings divided by their earnings. If I can do that and get a valid number, that's ratio data. If I take the two numbers and I can't get a valid answer, then it's probably interval data. When doesn't that work? It's hard to think of cases, to be honest. Temperature's the only one I can ever think of. So if the temperature today was 10 degrees, would be nice, and yesterday was 5 degrees, is it twice as warm? No, that's Celsius. If it was in Fahrenheit that I was measuring things, 10 degrees would be, 45 degrees Fahrenheit versus, 36 degrees Fahrenheit or something like that. Different ratio. So if I'm talking Celsius or Fahrenheit, I get different ratios. I can't talk of them in the same fashion. That I can't do division. We say in those ones they don't have a real zero associated with it. It's an artificial thing that we've created. So, but most of the time, you're probably dealing with ratio data. I wouldn't worry about interval stuff. If you get them mixed up, it's not the end of the world. Ordinal and nominal, though, are important because we can put them in an order, and that order is very important or helpful, or something that we may want to look at. That, but sometimes we do strange things, and it happens with ordinal data. It's one that always troubles me. So in this course, I'm going to give you a letter grade. I'm going to evaluate your performance. I think you're excellent. I take that word and I give it a letter, A. And then Banner takes that A and it gives you 4 points. And it feeds that 4 points in and gives you a summary, what your grade point average was for the term, your GPA. It averaged the numbers. Okay. So your GPA is 2.87. What does that mean? I took an excellent and I took a very good. I took two satisfactories, a bunch of those things, and average them. How do you average an excellent, a very good, and two satisfactories? What does that represent? I don't know, but we do it. It's called the grade point average. Um, it's very commonly done. People use them all the time. The people in psych and social marketing management, they love these things. They're generally using what's called a Likert scale and averaging them. They do frequently, so that they compare the average of one group to the average of another group. Think carefully about what it is and what you're measuring there. That Can you do it? It's always troubled me because it isn't. We're taking ordinal data, words, descriptors, and we're trying to apply arithmetic to it, and that always makes me uncomfortable. Today we have a lot of other data, especially text data. This has come about because we can now capture a lot of this better. Storage is now practical and not too expensive. That it used to be incredibly expensive and totally impractical to store information electronically. And if it isn't electronic, it's hard to work with. And now we can link computers together. So even if one computer isn't powerful enough to analyze this data, if I link 20 of them together, maybe I can. And so we've got Alexa Alexa, who wrote the song? It took that sound, converted it to words, had some tool for understanding those words. I don't know how that works. Found an answer to my question and then reformulated that as words and then took those words and then put sound to them and gave it back to me. Beyond what I can imagine. But along the way, that data actually is being converted. It's being stored, at least for the analysis, as numbers and categories. So it's taking frequency, amplitude, wavelengths. It's technical measurement type things. And it's actually analyzing those. But still, that's beyond my comprehension. So I'm out of time. I just want to run through the most important thing is that business problems are poorly defined. They're always poorly defined. It's very, very rare that someone can phrase their problem correctly right at the start. It takes a lot of work, a lot of dialogue, working back and forth with them. Maybe that's a role you'll play as being the go-between of trying to get good questions that are measurable. You won't be a technical analyst, but you'll help convert their issue into a data problem that then trying to find where can I get that data and evaluate issues to do with data quality. Particularly, it comes up with observational data and thinking of where can I get the data? What can I do with it? What are issues associated with that data? And the others that we get into as we go are going to become the technical issues. But these ones at the very beginning of how are you going to deal with non-response? How are you going to deal with bias that people are going to lie to you or not intentionally, but their responses are maybe biased or something? How is that going to affect your analysis and your interpretation? Knowing that it's present and even you've made adjustments, is that going to affect the way you communicate it to others? Because you want them to believe you. You don't want them to say this is fake news, that you've done a lot of work. You've done a lot of valid, honest, work with a lot of integrity. You don't want to be described as fake news. But if you're not careful, you're going to get that backlash back at you. And it's uh, people are becoming more skeptical today, I think. And that's gotten, in the US at least, the trust in science has gone down quite dramatically. In Canada, it's still quite high. But in many countries, trust in science has declined very, very significantly, and that trend may continue. So this is important to understand those things. Anyway, we're done with that. What's next? It's going to be Excel. And I don't expect you to know anything about Excel. That uh, the we're going to be starting at the very, very beginning. As we go through with the Excel, if you don't understand what I'm doing, you're going to say, I don't understand, Paul. Do it again. And we'll get you through it. You'll get hopefully comfortable with it. And even those of you that are comfortable with Excel, we may be looking at Excel in a very different fashion than you've used it previously. Not as a calculator, but as a tool, a repository for data, and a way of organizing information. Anyway, you guys take care. Let's end this. I'll record this and post it as soon as I can. Have a good weekend. Bye-bye.